Hello everyone, welcome to today's little stream. I usually do lots of things in Raylib and stuff. So recently I've been trying out the 3D support in Raylib. So I was thinking that I was just gonna show sort of how you can do 3D in Raylib with Odin. And then I'll show like some stuff like maybe some shadow mapping stuff and similar. So I just have a little tiny game thingy here. There is some shadows, some light, and there's this two billboard characters that have they're like flat and have a shadow like this, and I'm trying to go for sort of some kind of non-realistic rendering. Really, it's not. I'm not trying to follow all the photorealistic stuff. But essentially, it's just Raylib 3D, and I've put in some shaders for shadow mapping, and also have instancing running. There is some noise when you turn around here. Hello, chat. Yeah, this is some shadow map artifacts, but that I can take care of later. Anyways, so this little program, so I used my hot reload template that I think it's linked in the description of this live stream, and so that's just a template that sets up like Odin with Raylib, also with hot reloading. And that one originally was for 2D stuff, but I've used it to kind of try the Raylib 3D stuff. And what I've done here is, I've taken essentially some Raylib 3D examples, ported them to Odin. So what we will see here is a bit of a mishmash of things I've written, some stuff that I ported in from C and stuff. So we look at it, and then also I'm gonna clean it up, so you'll see me make it could look pretty at the end. There's sound noise in my stream. That's weird. I'll have to listen to that then. Hold on. I'm gonna check. I didn't do. There is almost never any audio problems, so I didn't do a sound check. But just because I didn't, then there is audio problems. Oh well. Fun. I will just check how the stream sounds. Yeah, there's almost dead quiet in here, so I'm not sure what. Yeah, there is some weird noise. I agree. Just checking my sound interface. I think the noise is probably back now because I disabled the audio interface temporarily. La 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 la. Perfect. Let's see. I don't think there's any noise now. Okay, no idea what happened there. I essentially unplugged the microphone, unplugged everything and plugged it back in again. And then the noise disappeared. Well. Sorry about that little intermission. Anyways, so let's just start over. So I have my little 3D thingy program here. And it has some shadows, and it has some kind of funny billboard characters, and this is all written in Raylib and Odin and stuff. It's not much of a game yet, but it's quite fun to play around with, because I put in shadow mapping, and I've also put in, what's it called, instancing and stuff, just to sort of try it out, and I kind of combined the two also. So what we have here is my Odin Raylib hot reload template thingy. It is linked in the description of this live stream. But essentially, this thing has some kind of init function, and then it has an update function also. This one. And like I said, this code is sort of a mishmash currently of things I've written, things I ported from C, from Raylib examples. So we'll see a lot of maybe mismatching naming standards and stuff right now. That's what we're gonna fix after I go through sort of what I've done. So it's gonna be a bit of a two-phase thing here. Kudos asks if I've been using RLGL. Yes, I've been using RLGL, and I'm using RLGL, which is Raylib's sort of abstraction on top of OpenGL for those who don't know. I've been using RLGL a bit more and more because, as we will see, I think you notice when you use Raylib, the 3D support in Raylib is that maybe you need to go into Raylib, look at what Raylib is doing, because Raylib is sort of a layer, you have RLGL, which is a layer on top of OpenGL, and then Raylib is a layer on top of RLGL. So you can go into the Raylib source and see what it does with RLGL. And sometimes you can port you can make your own versions of some of the Raylib code and work directly against RLGL when you need to. So this sort of thing has sort of a game update thing here, and using 3D with Raylib, you don't need to set anything extra up. So I have my init here, and sure, here I load some shaders and stuff. But to use Raylib 3D, what you need to do essentially is, so it's gonna see lots of this. We're gonna clean all that up. You need to, instead of begin mode 2D, you do begin mode 3D, and you send in a camera, and this camera, which is this one, essentially says, where is the camera, what's the target, what's the up vector, sort of what's up in the world, what's the field of view, and do you want perspective or orthogonal projection. Perspective is sort of when you get this perspective view with things being smaller at a distance and stuff. So that's sort of what you need. And in Raylib, so I can bring up the Raylib bindings here. What you can start with, I will show all my stuff a bit. What you can start with in Raylib, if you want to do 3D, you can just run the load model, and then you can start putting like an OBJ, some kind of 3D model format into this procedure, load model, and then you can run draw model with a position and a scale and a color. And there are lots of nice examples in Raylib, like if you scroll through the examples on the Raylib website, you will find, I think it's called, you will find stuff like this, like where you're drawing models and stuff. And some of these I have sort of ported a bit to Odin. But that's what you can start with. like load model and draw model and set up a 3D camera. And then you can sort of do stuff. And then you might want to control this 3D camera somehow, right? So what you can do then is in my case, I have sort of this is sort of like a first person thing where you can jump and run around, you know, classic stuff. What you can do for that is just to store a pitch and a yaw. So pitch is how much the camera is sort of angled on the local X direction, and the yaw is sort of how much it's turned. And you store those two as two separate numbers, and then you can just make two matrix fours like this. I use the linear algebra stuff in Odin here. It's a package. And then you just multiply them together. And then you have your matrix for sort of how the camera is rotated. And then you can just, what I do here is I take the position of the player, and as target I say the player's position plus this forward vector here rotated with this thing. So I just take a vector that goes forward in the world, and then I rotate it using this thing. And this thing is just a rotation around the x-axis and a rotation around the y-axis combined. And that's how you can get sort of a first-person camera. Depending on which order you put these here, things will behave a bit differently. So I have my camera there that is used for the 3D drawing. So if you have a camera and then you have your model that you're drawing, well, then you're on your way to sort of having a 3D game, right? One thing I won't show so much here is I have some kind of physics going on, but it's just hacked together. I want to replace it with sort of a walk mesh. So right now it's like the least optimized physics ever. It's just essentially looping over all the boxes and moving the player first in the which direction first? First in the Y direction, then the X direction, then the Z direction. If you do those separately and loop over all the boxes one at a time, then you can get fairly stable axis-aligned collision. Almost like it's not that complicated, but I wouldn't recommend doing that unless it's like, you know, just to get something on the screen. But I will replace it, this stuff here, with sort of a walk mesh, or maybe with a more proper physics. But I think maybe I would go for a walk mesh. Sort of, you know, if you play The Witness or something, you know, you can walk around on surfaces, but you can't just walk anywhere. It's actually, you're walking on a specific mesh in that game. Yeah. So that's sort of, I mean, it's not much more to it than that to get something basic on the screen. Draw model, and then a load model and a draw model. So one thing you might want to do is draw shadows, for example. And there is a great Raylib example, Raylib shadow map, I think it's called. Yeah, this one. I wonder if this one is available online as a preview or not. Raylib examples. Let's have a look. Shadow. I don't think this one is available online, the shadow map example. I think yeah, whatever. If someone finds it, then they can post in the chat, but I don't think it's available as a sort of online thingy. But you have the code here. And if we look at the code for I can just explain sort of what this does, because it's easier to explain from this code, and then I'll show you how it sort of sits in my Odin code. Or I can explain in my own code actually. But yeah, so there's the shadow map C file here, which is just a short example in C like this. And you see this is RLGL. Everything that starts with RL in C here is RLGL. And then it also uses two shaders that we see here. And these shaders you find in the resources folder, shaders GLSL330, and you go into shadow map, these two files here. So this is the vertex shader, and then it's the fragment shader or pixel shader here. So in my case, what I do is currently I have a hard-coded light pos, I think. Yeah, so my light is here at these coordinates. And then what you do to get sort of what a shadow map is that there is from the position of the light, which is somewhere behind me in this scene, there's a lamp there, and you take a camera and put it at where that lamp is, and then you draw the whole scene from the viewpoint of that lamp, that light, and then you record that in a separate texture, but you only record a depth. So you record like how far away is each point on the screen from the perspective of this lamp. That's what you do. And then when you have that info and you're drawing, you know, things from the perspective of me walking around here. I can look at this shadow here, for example. So what I do then is that when I finish drawing sort of the shadows from the perspective of the lamp, I also save the matrices that tell me how you can get into the space sort of that light camera, sort of how to get there. So then when I'm looking at a point, for example, somewhere here, then I can take this point on the screen and transform it so that it is as if I am looking from that point over there, and then I can compare the depth values. So if this point here I'm looking at has a greater depth value than it has when looking sort of from the light source, then it is in shadow because there's something in the way. Like now this is not in shadow because this is the camera at the light sees this, but this is in shadow because there is no point that over here with this depth value at this point that the light camera can see, sort of. So that's sort of what it does. That's the sort of the intuition of what it does. So when I draw, so in order to get that texture, that light mapping texture, what you do is, so I have my init function here, and I have a shadow map here, and I say create shadow map render target. And this is maybe a bit overkill resolution, 4000 by 4000, but this thing essentially, and this code is in that shadow map thing I showed on that I googled up. But I ported it to Odin, and essentially this thing just creates, it loads a frame buffer and creates a depth texture with the width and the height needed. So that's sort of the texture it will draw those things into. And that's sort of, this is all there is to it, really. You know, this thingy doesn't even have a color texture. So when you render to this thing, it will actually not even save information about how everything looks. It will only save what's the depth value. You know, this is also called the Z buffer that is used for sorting things on the screen. So that's the only thing the shadow map needs to save is a depth. Yeah. So you have created that one, right? You have that stored away somewhere, and in the draw function here, then I just say I create a camera that looks that is at the position of the light, and currently my light is sort of looking from the position of the light towards the origin. I haven't set up sort of so that it has a proper direction. My direction is from the light source to the origin. You should probably set up your light so it has like either it's because it's a directional light, right? So either you should set it up so that it has a point and a target, or that it has just a direction. I set it up so that it's currently only a position and the lamp has as target the origin. But yeah. So, but I do that anyways. I say that I want to draw into my shadow map here. This is the first thing that happens in the frame. I want to draw into my shadow map. I clear the shadow map white. And the shadow map, I think, is just like one. It's just one channel, like like a 32-bit red texture. So I make a light camera, and this is an orthographic camera that has a very sort of this narrow field of view. And then I say begin mode 3D with this camera, and then I draw the whole world. And draw world just draws this stuff here, and then it draws it into the texture. And what it does here is that it saves the view matrix and the projection matrix. The view matrix is the matrix that says where is the camera, and the projection matrix is the one that says how does the camera look upon the world. How does it like if you have a projection camera, then you know it will make things smaller at a distance and stuff. In this case it's an orthographic camera, so it doesn't do all that stuff, but yeah. And then I just and then I make this the light view projection camera, and this is the matrix that I need later to be able to, when I'm running around like this, I need this one to later look at, when I'm looking like this, to be able to transform sort of whatever I'm looking at here to so that it is as if it was looking from the viewpoint of the camera, so I can compare the depth values, because in order to compare two things you need to be looking at them in the same space, sort of. But yeah, and then I set this I think there might be a potential bug here that it uses the same shader location in two different shaders here, because this is the default shader and this is the default shader instanced, but I think it just happens to work. But I can fix that. So it just sets on the default shader, and this is the shader that will be later used to actually draw the world from the position of the player, right? So it takes the that matrix and just puts it there, so that shader can later use it, and then it starts over. It's like, okay, begin mode 3D, but with the camera, and this is the camera that I already showed you, that's from the position of the player, that has sort of kind of first person control. So it says that, and then it also draws a skybox. A skybox is just like, this is just a cube with some normals that sort of moves with you, so you're always inside it, so you always have sort of a blue sky around you. Not that it's not terribly important right now. And then I draw the world again, right? And then down here I say end mode 3D. But what will happen now in draw world, which is this thing, and like I said, we're gonna clean all this up soon, but in here I say shadowcaster bool. So if I'm a shadowcaster, then I say use the shadowcasting material, and if I'm not a shadowcaster, use the default material. Chris is asking, what are you using to load models? Just some inbuilt primitives. Yeah, I think you can I think I use this one, a cube. Well, actually, I think I load a box here, but I could use this box or this cube. I just tested both here. And then also for the characters here, there is planes. So for those I generate a mesh plane, right? So, but in draw world then you can be like, okay, I'm gonna, and this is my instance drawing, which I can talk a bit about as well, but for the shadow casting, it just says, are you casting shadows, then use this material. If not, then use the default material. And this material uses one shader that is a bit lighter, that doesn't do anything fancy. That's used for drawing the depth into the shadow map. And this one samples the shadow map and everything, and has this material. If we look at it here, this material I create with rl.load material default, and I say that the shader is the default shader instance, which we can look at in a bit. And then I say that the texture, this texture here, is the shadow map, right? It's the depth texture in the shadow map. The color texture in the shadow map has nothing in it. And so that's sort of what it does. We can look at what drawMesh instance does later, because as you see here I commented out rl.drawMesh instance. So what I've done here, I actually ported this procedure from C to Odin so I could customize it. Accusart says, funny how all this rasterization stuff is much more complicated than any basic ray tracing, yet somehow it runs fast. Yeah, I guess it's like an optimization. Well, yeah, it's one of those things that is simpler, but to make it look good, you have to go through so many hoops, in a sense, you know. But it is a bit funny. It's I was gonna say that it's I don't remember, but yeah, it's you are correct. So this shader then that it draws this stuff with is it's called default. Well, we can look at the shadow caster first. Shadow caster vertex shader. The shadow caster is super simple. Shadow caster instanced. We can look at the non-instanced, but we can look at the instance later. So the shadow caster just sort of like takes the model view projection matrix, which is the combination of all the different matrices for where the camera is, the projection, and what position this object should have. When you do instancing, the transform will come in like this. I don't know why this is even here, but because shadow caster instance should have the transform like this. But anyways, for the shadow caster, you just in the vertex shader just do this, right? That's mostly what you need to do. And then the shadow caster fragment shader, you barely need a fragment shader in some cases. If you only if you have only 3D models that have where the geometry sets the shadow completely, then you don't even need this. The reason I have it is because of these guys, right? This is a square like this, yeah. Then it's a texture drawn on it. But in order for the shadow to, in order for the sort of the camera that sits at the light to see through this plane, it must sample the texture. And if the alpha is like if it's fully transparent, then it just discards that pixel completely, so it can look straight through it. And that's why I have this fragment shader. It takes a texture and the text core that comes from the vertex shader comes in here. It samples it, and then if the alpha is 0, then it discards it. This is a little hack I put in. I'll show you what this does later maybe, but it's not that important. This is just because of my instancing. I needed some way to pass some extra info. So that's how you draw when you, and I can actually even enable. I have a funny. Or did I remove that? I think I have a funny thing down here. Yeah, this one I have. I can enable this thing. And then you see the thing you see in the top left here is that's the shadow map texture. It's quite hard to look at because you can't really see any differences really, because the shadow map, I don't know if it's because it's not normalized, so it goes over one very quickly, or something. But anyways, when you visualize like this, it can be hard to see. But this is so essentially, it's the, I'm trying to get the mouse cursor. Wait, I do like this. So this part, this stuff here is just, you know, the top I'm walking at, and this block I'm walking at is very tall, as you see. So if I fall off it like this, see it disappear. Yeah, and then this thing over here is this little thing down here that I can jump down to. But that's what the camera over at the light sees. That's the texture it draws. So it's nice to have little rendering. When you do something like this, you can take your depth texture and you can render it on the screen very easily. This is one line. Draw texture, take the depth, draw it at the origin up on the top left, and then I scale it down a bit so it doesn't take the whole screen. You can scale it down more so it like, and like this you can have a button to just show these and have them as some kind of debug info if you want to. You have different sort of textures that go into your rendering. Lord of the Six String says, anyone find Raylib's mouse clicking bad? It eats my mouse clicks so often. I think in the examples maybe they capture the cursor. So here, this is fine. I've made it so that disable cursor. I've made it so that if I press X while the window is focused, then it captures my cursor, which means it just enables it, and then it disables it if it's already enabled. That way, because otherwise it's hard to do a first-person camera, because when you run to the side of the screen, you can't turn anymore. So I press X, and then it captures the cursor, and then I can press X again, and then it uncaptures it. Hello, non-unknown. Thank you so much. Yeah, it's probably like Stefan says. Like maybe the depth texture is like a 0 to 255 range, or like it's just another range, and you just see part of the range. So whenever there's anything at all in the depth texture, we sort of see it. I have trouble with. Yeah, so maybe when it's almost nothing at all, like when maybe if there's anything at all in it, it just draws and it looks almost black. But yeah. Anyways, so then those two shaders I showed, Shadowcaster vs.fs, they're by the way loaded in game init here. Like I kind of like, oh, Shadowcaster shader, load shader, blah 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 blah. And this is the instance version, which I will show later. So the instance and non-instance essentially means that for the non-instance, I can draw one thing at a time. Sort of like, okay, draw a box here, draw a box here. If the instance one, as long as they share the same material and the same mesh, I can make a long list of transformations, like matrices. That's just like, here, go, render. Here are all the different places you should draw this thing on with this material. And then it goes and does that. But we can look a bit at more of that in a bit. So as for the lighting for the Shadowcaster, what's it called? So like I said, in draw down here it says begin mode 3D from the normal camera, and then draws a skybox and draws the world. You might notice I've commented out the shader mode here, because the shader is actually part of material being drawn, so you don't need to declare the shader mode explicitly like this, which was what I did initially. But so then, in case of Shadowcaster being full, when you run draw world, it uses this thing that uses the shader for actually using the shadow map, and that one is the default lighting.vertex shader. The vertex shader is super simple. It just takes model view projection matrix times the vertex position. This frag positioner is a bit of a bad word. It means it's actually the world position, because this is the local to world transform matrix, really, the model matrix that transforms the position of each vertex on the thing to where the thing should be in the world. And then the normal is takes a normal of the thing times the normal matrix, which is sort of a funny matrix that is a combination of it's essentially the inverse, the transpose of the inverse of the model matrix, but it's not terribly important right now. You can read more about that separately. And like I said, these are actually from the Raylib examples. So it's a bit of a mishmash of me combining different things here to do something interesting. And then when it has passed through this vertex shader and it got to a pixel, and this is the one that, and here it's a bit of, here I do all the lamps, this like a maximum of 4 lamps, and like I said, this is also from the Raylib examples. If you find this is probably might be part of the shadow mapping or the instancing or some lighting example. You can find all these different examples by just googling Raylib something example. But what this thing essentially does, it's quite a big thing, and we'll clean this up in a bit, but it will, how to say, it's a bit messy, so I'm just trying to. So one thing to notice here is that we have the light VP here, right? And we have the shadow map. Light VP is the matrix that brings us to whatever the light, the camera that sits at the lamp that render the shadow map. So you can bring your world positions to that. And that's sort of what we do down here, right? So if we go and look at this stuff here, so here we take frag pos light space. So we take the frag position. This is the world position of this pixel. Where in the world is this pixel? And you multiply that by the view projection matrix of the light. That then brings it to where the light is and sort of how the light looks at the world. So that it sort of, it is as if it looked from the light source on this one, so that the position, essentially a point in shadow, a point not in shadow on here will have the same depth value when I'm looking at this stuff on this pillar here, as if the light camera that is over there looking at it, so that you can actually compare these two depth values because they're in the same space. And then this is the perspective division. So this is usually what I think homogeneous coordinates do. You divide by the W, and then it transforms this, because this will be in a range from -1 to 1 after this has happened. So it transforms it just so it's a 0 to 1 range. I think this is just to match whatever my depth value, the depth value in the texture is. That the depth, like when it writes the depth value while the image is being created, then it will write something apparently in the 0 to 1 range. So then it can get the sort of current depth is the Z component of this. So that's the depth of every pixel on the screen if the camera was looking in that direction. But now, because I stand over here, I can see behind this pillar. So this point here will have a depth that is higher than the camera could see from this direction, because this camera was blocked by this pillar, right? So then it also takes out a sample position here, which is the XY part of this thing. And that's the thing it can use to sample the shadow map down here. So this is a little algorithm that's also part of the example, percentage closer filtering, but this is just, I would say this is just a thing that takes multiple samples in order. It's just some kind of anti-aliasing, because it, instead of taking one point, it takes a couple of different points around it and then divides by how many it took. But here it samples the depth, right? So it takes the shadow map and it then says to sample it at the sample chords plus texel size times xy. This stuff here is just because so it gets this offset from these two loops to do this PCF thing here, right? So I know that the texels are 1/4096. This is the resolution of the light map. I just hard-coded this here. I should send in the Raylib example, they send in a value here, but I was lazy. So I just hard-coded it there. And then, you know, this will offset the sample chord by a tiny bit based on the X and the Y here. So, and then it runs through this and it will sample it 9 times. And for each time it comes in here, it checks, is the current depth, we can ignore the bias right now, is the current depth bigger than the sample depth? It means that, is the depth at the point, so if you look at the middle of the screen, is this point here, does that have a higher depth value than whatever the light recorded when it looked at the world from its view, which is the light looks at it from this view, and we have transformed our fragment position so that it also sort of looks from this view, but we actually have data from looking over here, so we see sort of behind it. It's a bit of a funny thing, but that's essentially what we do, because we do the coordinate transformation, right? So then we can just check, is the depth bigger than the sample depth? And if the depth is bigger than the sample depth, then it means that you're behind something from the viewpoint of the light source, and if something blocks a light that is looking at something, then that thing behind it is in shadow. So then we say shadow counter plus plus here. And shadow counter here, shadow counter can then be used down here to just, I use it in a bit of a funny way here, but you can just use this to blend in sort of like, I think I can show you what they do in the original, this is the original one. So in the original one, they have the color. The color is sampled from a texture, I think. So they have used some nice texture on their object. That's the final color. So they mix, which is a lerp. They mix between final color and this totally black color, which is a bit of an extreme shadow color. And the closer, like if shadow counter is 9, because num sample is 9, right? If shadow counter is 9, then this will be 1, which means it takes full black. That means it's full shadow. And then it can be some tiny variations at the edge, really. But yeah, that's how you get into shadow. You lerp towards black based on the number in this thing. Because, and this number will grow when the more, like if essentially if you ignore this stuff, it's essentially just, is the pixel we're looking at on the screen from the viewpoint of the lamp, does that have a higher depth than whatever the shadow map has? And that's the shadows. And then this old stuff down here is some other stuff for doing some ambient light and stuff. So that's sort of the basics of shadow mapping. And, you know, this kind of PCF stuff, this is, you know, people usually discuss this in books as some kind of extra thing. The Raylib examples come with this implemented. It also comes with some kind of bias. Oh, the bias I didn't talk about. So if you set bias to 0 here, I can show you what happens. you see that everything is very, you have like tiny shadows everywhere. So what the bias does, it just sort of offsets the current depth a tiny bit. And the bias you need to sort of tweak based on how far away the lamp is. So there's no good single value for this. And then you can also vary the bias based on the norm, like the direction to the normal and the light. So there's some different funny things you can do there. And that's just to I can show you what happens if the bias is too high. No, I mean too low. Yeah, here you see how this shadow starts like away from the... No, I meant actually too big. I went the wrong way. So this is a too big bias, so it offsets the depth too much. Then it looks like that. So you have a couple of different things to tweak there. So if you can tweak it based on how far away your light is, you can sort of find a nice value, and then you see here it's sort of almost perfectly lines up with this thing. And you know, this is dynamic, so we can go to we have set light here. We could say this light pos equals this and that, and then we hot reload this, and then you see the light source is moving, and you can see how the texture in the top left is rotating also, because that's the point that the camera is looking from. So that will, yeah, that's what the camera at the light source sees when it renders the shadow map. And so it's kind of fun to see it all just rotate around like this. Yeah, that's sort of shadow mapping. You can I will link in the chat shaders shadowmap.c. So I've taken this example essentially, and I just looked at it and I ported the important parts to Odin. You can sort of see here, begin mode 3D light cam, this stuff. I just ported this to Odin essentially. I've done some things slightly differently, but... And then the shaders you find in... For example, this is the fragment shader, or pixel shader, whatever you want to call it. Chris PHP asks, how would a day and night cycle be done? So having a light source that moves is a good first start, right? Then you could have a dynamic sky dome that the sky dome knows where the sun is. So you have a very fancy shader that sort of tries to, maybe if the sun is close to the horizon, you make the sky a bit redder, and if it's high up, the higher up it is, you make it like blue and pale-ish, almost white. Then maybe on this sky dome shader, you could also put in some little shader to like procedurally generate clouds or something. So, and then you could color those clouds maybe a bit more red when, you know, you can do all those kind of things. That's just sort of tech artist stuff. But that shader needs to know where is the sun right now. So this rotating light here, for example, you would need to feed it, right? And then you could also change the light color's color. You know, the light itself, the lamp has sort of a color that it colors the world with. So you can also change that one, become slightly more red in the evening when the sun is low. And that's just sort of, you can use some, well, you could use sort of a dot. You could use dot the sun's direction with the up vector. If it's close to 0, then you're almost at the horizon. If it's underneath, then it's sort of night. So if it's positive, then it's day. If it's negative, it's night. Something like that. I don't know. And then yeah, I think that's a good start. Then you can do sort of, you know, all these kind of crazy post-effect stuff also. But I think if you just change the light color, have a dynamic sky dome that acts on the light position. A very good start. And I mean, you can make a shader that I think I have a shader for my sky dome. Sky, what's it called? Skybox. Yeah. You see, this skybox here is actually. I think I can. You see, I have a dynamic skybox. I just don't use it, but it doesn't know where the sun is. But this thing is just it just knows how it checks how much up does the position of my position on the sky dome. How much up is it? That's just a dot product between the direction of the frag position and the up vector. And then, you know, I can do silly stuff with that. I should code in here, maybe throw in the sun position and then just put it there. I think it would be pretty cool. I want to do that later maybe, but not now. But maybe we can put in a tiny bit of, like this, plus upness. Let's do this. Suddenly we're making shaders. I just got excited. Plus Vec3 0.1, 0.1, 0.1, maybe, times upness. So then when it's all the way above, you see now it's hard to see, but it's a bit, maybe we make it a bit stronger then. Yeah, it's something. It's a bit paler at the top. It just looks a bit nicer like that maybe. Anyways, let's look at the instancing. So we've looked at the shadow maps, I've linked those, and I will put them in the description of the live stream also later if anyone watches afterwards. Let's look a bit at the instancing. There's also a nice Raylib example for instancing. We can look at that, show you where it is. How do I instancing this one, shaders mesh instance. Yeah, so here is the C code for this thing. I will link it there, and then this one. The nice thing is that the instancing one uses. There's a lighting example as well that does like a Phong shading thing, and the lighting, the instancing example uses the same lighting, it just switches out the vertex shader. It uses the same pixel or fragment shader, so you just need this one. That's the difference from the lighting example, which you can also find on the Raylib examples page or something. But what you need for instancing is essentially, if we look at the shader, is maybe easiest. Default instancing. So usually you can compare two shaders. Usually default lighting here, usually you get a model per, like this matte model. This is the world transformation of where you should draw one specific 3D model. That's the matte model that gets sent into my default lighting. However, in the instanced case, in the instanced case, you see here I multiply by instance transform instead of matte model. Instance transform is not one of the uniforms here. Uniforms are uniform in the sense that they have the same value for everything that's rendered in this draw call. Like for even if you render a bunch of different meshes using instancing, you still have the same uniform matrices. But here there is no matte model like we had in default lighting.vs. Here we have a matte model, in this case, there is no math model. Instead, as an vertex attribute, like an input here, these are usually the things that come per vertex. So you have the position and the text chord and the normal. It's for the points in 3D. It's for the points that make up your mesh, these different things. And what the vertex shader does, it transforms these things, the position and the text chord. Well, it doesn't transform the text chord much, but it transforms the position, and then it feeds it onwards on the GPU, and it will get interpolated. So the fragment shader, like if you have two vertices, then the fragment shader will fill in all the pixels sort of in between them, or fragments as you might call them, because they're not really pixels yet. And it will interpolate. So the vertex position between the vertex position between up here and up here will be sort of it will interpolate that, and it will run the fragment shader for each value. So you can do sort of think as the vertex shader being run less often and the pixel shader being done very often for all the things in between. That's why the pixel shaders are much more expensive to do one thing in a pixel shader than do it once in the vertex shader. Which is why, I mean, you could send in the vertex position, interpolate it, and then multiply by a matrix in the fragment shader if you wanted to, but it would be much more expensive because then you do matrix multiplication in the fragment shader instead of the instead of the vertex shader. But anyways, so in the case of instancing, you see the instance transform comes here as an in parameter, and it's used down here. So it doesn't come as a uniform matrix anymore. And these can vary per, I mean, in this case here, it varies per vertex, but in this case, this will vary per instance, which is sort of once per model or whatever you want to call it. If you look at some later versions of OpenGL maybe, or if Vulkan, then sometimes what you can get instead is you have like an array. You can have like an actual array of transforms. So it's like, 1,000 transforms is here, and you just fill it, and then for each vertex, it is just fed which instance number is this. So then it can just index that array. So it's sort of more, you move more responsibility to the shader, and it's sort of less things to set up like now in OpenGL, because now I must set up this a bit more in a sense, because I don't just throw a array at it and then have an increasing instance counter that I can use to pick things out of the array. Instead, this one is sort of advanced, one transform at a time for me and put here. But this will make it so that I can have different transforms for different models, even though they're drawn all at once with one draw call. And draw call is just, you use a mesh and a material, and you tell it to somehow draw. And in this case, I tell it, can you please draw, like, for example, this pillar here and the ground I'm standing on, or these two characters here, they're drawn using instancing. So it just says, for this ground box, the big box here, it is upscaled and has a certain position. This is scaled in another way, has a certain position, but they both share the same mesh and the material, and then those transformations for the scale and the position and stuff, those are sent in a big list to the GPU, and then the vertex shader can access those here, and then it can very much more efficiently draw those. I mean, this is just a toy example here, right? This doesn't need to be drawn efficiently, but so in order to set these things up, this instance transform, because like I said, the fragment shader is essentially the same. It is the same. I use the same lighting one because it just passes on the frag position like before here, and down here it also, the GL position, it produces like this, right? And here, you know, MVP stands for model view projection, which is, it takes the world transform, the local to world transform, plus the view matrix, plus the projection matrix, puts them together, and then sends that off to the GPU. In this case, MVP is a bit of, I would say it's a bit of a bad word, because the model part, which is the local to world, is actually in here. So this is more like a view projection matrix times the instance transform, which makes it into a model view projection matrix. But I do it in the shader because that's where I have the instance transform of each instance. Anyways, so in order to set this up, you need a couple of different things. I say on my shader, default shader instance here, I say, okay, the instance transforms list, I will use, this is just what the Raylib example does. I don't know if I agree with this, but it uses the shader location of the matrix model, since it doesn't need that matrix anyways, since that's the matrix that's usually used for each separate one. It uses that to store this big list of instance transforms. So, but here you can see that when you, for example, set up a, what's a good example? When you, for example, set up the, when you, for example, set up this view matrix here, then you run, this is just a procedure I made to make this prettier, but what that one does, it sets, in a list of locations on the shader, it sets the shader location with this name, matviewpos, and the thing at shader location matrix view, it sets to this thing, right? In this case, it sets here, this is very easy to miss, that this one says shader location, and this one says shader location attrib, right? And this is to make attributes. So essentially it's because this one comes in as attributes. The instance transform comes here. It doesn't come down here as a uniform, right? So that sets that up. So it says that instance transform, it will fetch the location of the attribute instance transform here, and it will set it at this index, and this index is the matrix model shader location index that comes from Raylib. I should also mention here that just yesterday or 2 days ago, I put some work into, because we had RLGL, the GL abstraction layer thingy that sits on top of GL that Raylib uses. We had that in, but I've made it so that you now get it in a separate sub package, because before you had to write like stuff like this because it was in the same package as Raylib. Now if you import RLGL like this, you can write RLGL and dump, like remove this, so it's like it's not rl.rl blah 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 anymore. In my case, I also aliased it locally to RG for RLGL. But this change is merged into Odin, the Odin vendor library now. So RLGL is, Raylib is written on top of RLGL, so you can essentially use RLGL without Raylib to do things. And what we can look at now, related to that, is, are we done in game init? Yeah, kind of. Yeah. So if we look in draw now, what I do in draw world here is these are the, never mind the name NPC rects here. It just came from down here because I needed to put in some UV rects because I have an atlas with all the textures in. But so this is actually empty. So, but ignore that. Here I make a list of transforms, and these transforms are the scale and the position of each box. So I have a bunch of boxes, and these boxes are these things that we can look at. This one box down here, one big box here, and then it's a small tall box here. That this takes the scale times the position, and it makes it into an RL matrix and autocast here because this changes from a column to a row major representation. and then it uses the instance material. And usually in Raylib, if you draw, you have draw mesh, you can just use draw mesh and say which mesh, which material, and which transform. You can just do that. You don't need this instancing stuff. With instance, you say which mesh, which material, and then please a list of transforms and how many this list contains. This should really be num transforms or something. That's what it means. So that's what the original rl.drawMesh instant does. I think I can maybe still run this procedure. No, I can't, because I changed some stuff in the shader, so I can't use that one anymore. So that one was the one I ran before. And that one is a bit of they show you how to use that one in the example I linked. So here I'm gonna tell you something that I think if you use Raylib from Odin, especially if you use the 3D stuff, you will need to look inside. What is Raylib actually doing right now? You will need to do that all the time. So in your project, just pop out the side view here. I have both I have the Raylib bindings here, but I also have the full C source of Raylib here. So I can write draw mesh instanced in my go to symbol, and then I can go to R model.c and look at what the C code does. I do this all the time because you need to do this, otherwise you're gonna scratch your head forever and don't know what's happening. But what you can see in this C code here is that it takes the transform list that you send in. Like I said, this is in Raylib, and it makes like a list of instance transforms, and then this stuff here uploads it to the GPU. And here you see the shader lock matrix model. So it expects the instance transforms to sit at the shader location matrix model. It doesn't have to be this way, but that's what it expects. So you have to use that if you use this procedure. So that's the stuff in game init, this stuff here, set shader attrib location here. It sets it on matrix model with this name, and this is the name the in attribute in the shader has, and this is the shader location, and that's the one that drawMesh instance will use. So I'm not gonna go through this one in detail, but you can see here that you can just already see that, okay, it sort of enables some vertex attribute. Okay, that's it sort of enables this thing here, and then what this line here does is that it says we're in the current bound buffer, and the buffer is bound here because this is where it uploads and binds the buffer with all the transform in it. It says where are the different parts of these transforms, because a transforms is 16 float numbers, so it can only do 4 at a time, so it needs to say like here are the first 4, here are the next 4, so that's why there's a loop here. And then this thing here is the attribute divisor, which means that if this is 1 here, it essentially means use instancing, because this is how many for each. This is how much, like if you put 10 here, then for every 10 instance it will expect new data or something like that. I don't remember exactly, but it's essentially, usually for instancing you would want 1 there, and then it just does a lot of blah blah blah. And you can look at this one at drawMesh instance, and you can look at drawMesh, see how they are different in the C code. All this is probably not used because this line runs, and this enables the vertex array object, which is sort of a preset up sort of list of where things are. And then it just at the bottom here, it just draws here. Draw vertex array instance, and then it says how many vertices and how many instances, or if it doesn't have a index array. This is either your model comes as a couple of vertices plus indices of which vertices to draw, or it just comes as a list of vertices and then it just draws them in some way using just the vertices. But this is the thing that essentially draws it in the end. This is what emits the draw call. So you can look at all that, but a thing you see here is that this thing here sort of makes the assumption that, oh, you want instancing, and by wanting instancing you mean that you want just a transform per instance, which means you get one transform per model, per kind of thing you want to draw. Which is fine for the example that we had, but what I wanted then was, if you look at this stuff here, I wanted, you see you have these two guys here, and they have sort of a texture on them, and I thought it would be cool, because I've done experiments before with, turn off the rotating light. I've done experiments before with making an atlas. So I have a small program that builds an atlas, right? So an atlas is sort of, this is my atlas here. You see, and this has a font in it, but it also has these two pictures. And this is the only texture that is bound, because I only have one material, right? Because when you run in Draw World, when you run Draw Mesh instance, you have one mesh and one material. And on the material, I set which texture. I could also have a list of, I could also have an instance data that is different textures somehow or something. But I thought it would be cool to try to use the atlas for that. So then I needed to feed in the rectangles somehow of what data to grab out of the atlas. So this is the code for drawing the boxes, and down here is the code for drawing the sort of NPCs. And what you see here is just, it's similar, but it has this get NPC transform, because these guys sort of, currently they're facing you all the time. I might draw, this is from Cat and Onion. I'm not going to use these two probably. Maybe there can be Easter eggs or something. But maybe I want like a 4 directions, so you can see the person from the back, from the side, and from the front. And as you go 90 degrees around them, maybe just snaps which one you see. But anyways, that's the get NPC transform, makes that matrix. So that's the thing you throw into the NPC transforms here. And the NPC rects is, then I have this list of atlas texture. I have atlas.odin, which has a mapping between texture name and this thing has a rectangle, and this is where in the atlas that we just looked at, this thing, what are the pixel coordinates, the rectangle of the squirrel and the cat here. So you see you have these two rectangles. So then I feed those two in there, and then so what I've done then is that, and this is also a nice thing I think about having the source code easily at hand. So I took Draw Mesh instance, and I just copy pasted it to my Odin code, called it Draw Mesh instance, and then I went through it and started porting it to Odin. And this code still needs some like all the naming conventions of local variables is currently not consistent with the rest of the program. Everything is quite inconsistent here right now. Never mind that. But I ported this to Odin, so you can see sort of, yeah, oops. You can sort of see how it's mostly the same thing. And porting C code to Odin is quite easy. You can see here all the times where it was RL enabled shader here. Instead I say RG. If you import RLGL, it would be like that. Before I changed the bindings, it was like this RL.RL enabled shader. it was a bit awkward, I thought. So that's why I suggested that we put it under RGL package, which I have alias to RG. But what I did, the reason I did this was because I wanted to get that instance data for where to grab the UVs for the different characters from. I guess I could have had separate textures or something also, but I just thought it was fun. So this is probably a better way to do this, but that is left as an exercise to the reader. But I have default lighting instance here. And what I do is I take the vertex chord, because this will probably need to be changed anyways, because I want to be able to have boxes with textures on different sides. And this one currently assume it's a plane where the texture chord goes from 0 to 1. But I remap, which is just if it just remaps from the range 0 to 1 to this range over here. So if the X vertex chord is 0, then it uses this value, and then it interpolates all the way up to 1 using this value. And these are the things. This is my extra instance. I call it the instance UV remap. So it's just a thing for going from the 0 to 1 coordinates of this plane which the character uses to going to a smaller rectangle. So these things will sort of be like, this is the starting X position in UV coordinates, so a number between 0 and 1 of where this is in the 0 to 1 coordinates, and then it's the same thing in the Y range. So that's what I did here. So I just made you see, this is, like I said, this is the same as draw mesh instance in C, but I converted it to Odin, and then I make another list here. And here are my instance transforms, but here is my UV rects, and oh yeah, this is also because of copy pasted C code, the indentation. We're gonna fix that soon. But here I just go like, okay, this is the X position divided by the atlas width that gives sort of a UV coordinate, because it sort of gets normalized between 0 and 1. So if this was at the far, like if it was at the right edge of the atlas over here, it would have the value 1. And then the second one is where it ends. So it's like, where does this cat thing here start, and where does it end? So this is the start, and this is the end. And then the same thing in the Y direction. Where does it start, and where does it end? So it's from here to here. So I just get that sort of remap thing. Yeah. So then that's what happens here. It just remaps that, and I've added the instance UV remaps down here. You see, I have a new shader look. So here is the matrix model stuff where I send in the instance transform stuff. It loads and binds that buffer here, and here it loads and binds the buffer with the UV remaps in. Note here, since I ported this, I could easily change this to be somewhere else. I don't need to like reuse the matrix model shader location anymore, really. I just haven't changed that. That's a nice thing about, porting things to your own stuff, that you can. And here we see sort of why I think it's important to you have the Raylib source, the original C source. Even if you're using Odin, you can easily port the C code over, and then this code in turn uses RLGL a lot, because this is the sort of more low-level Raylib code. So here I just use RLGL, and slowly but surely, if I do this more and more, maybe at the end my program will only use Raylib for opening window, playing sound, doing input. Maybe all the 3D will just be me using RLGL, which is sort of like just using a abstraction of OpenGL for that, and that's fine. Right. So this shaded locations UVs is just a constant I put here. The shader location index in Raylib looks like this. It is how many values? 26 values. Raylib is, by default, I think it has a max of 32 shader locations. So this one is 26, so the 27th one is my shader location UVs. I'd rather just be outside this one, define something myself, than just reuse stuff in here. I can reuse stuff in here if I run out of them, you know. But and I do the same thing here, you know. I say set shader attribute location, shader location UVs, and then it's the name. So that sets up the in attribute in the shader so that it knows where this one is. And that's the one that we use down here then. And yeah, and then that way I got in the, because the texture, and then I also bind the atlas, of course. The atlas game init. I'm just looping around here. You see, I set on the default material, and I also set the atlas here as the texture at slot 0, which is actually me being lazy. That's the one Raylib uses for the albedo. You see, this is shader location index map. Map 0 is this one. So it's essentially, yeah, that's 0. And since I have the vertex code here, and then in default lighting .fs here, I sample the texture using the frag text code, which is the interpolated text code between this value and this value, which is the one I sent in. Then I can use that. And I also discard the thing here. I don't know if I really need to do that because I got alpha blending in this case. I think this is left over from when I used this shader for the shadow casting as well, but the shadow casting uses its own shader nowadays. Stefan Stefanov says, every time I make some 3D stuff, I always run into the issue of trying to make a nice universal abstraction for shaders / materials, and I'll fail at it hard. I have worked with professional rendering programmers that have made several game engines, and they say one of the things they always hate about their own renderers in their own professional work is that it's almost impossible to make a nice material system. They always hate, like, or shader system, like that, those kind of things. You always think that's going to be good in the beginning, and then at the end you hate it. And those people, you know, they're making general purpose game engines, so you need to make something that's flexible so that everyone can use it. If you're just making something from scratch yourself, you might not even need a material system. Like, especially if you are just sort of kind of a programmer who does everything yourself. Because, I mean, draw mesh instance here, yes, sure, it takes a material, but I could just send in a shader here and some parameters and just set some stuff up. Or at least you could make it much more sort of bare bones. But if you're making something that anyone else should use, then you're always in trouble because they will maybe expect a material system. But if you're making something for yourself, I'm quite looking forward to maybe scrapping the material here. Because I have absolutely no wishes to make photorealistic rendering. I like, for example, in default lighting here, I have this thing called distance darkening. I can turn it up a bit so you see it more. For example, like I'm just doing like random effects like this sort of. Oh, this one got. Is there something wrong with this one? View pause, frag pause. Interesting. This one is supposed to follow the view position, but I don't think I write the view position properly. But you know, I try to do things like I know basic Phong shading with, you know, how to calculate if one side of an object is in sunlight or not, so that you can make like sort of the backside of things darker. But then, you know, and that thing will usually come with kind of specular highlighting. I just threw the specular out. I mean, I can, and I don't like also, like, usually what you do is you make things darker on the back and then you make it brighter on the front. That's actually not kind of at all what is happening here. What I've done instead is I've calculated, I didn't show this much before, but this just runs through all the lights and it takes the dot product between the normal of the surface and the direction that the light hits the surface at, or rather the direction the light leaves the surface from. And that's normal stuff, taking the dot. And then some people used sort of kind of that dot product to make their surface darker or brighter. But instead I make a color ramp that goes between this color here and this color here. And I pick, this is sort of a bluish color and this is sort of a warmer color. So I pick something on there times the color of the lamp. I still call this light dot because this is ported from the Raylib examples. And then I multiply that on there. So then I'm instead of sort of making it lighter and darker, I'm sort of more kind of recoloring the surface, which kind of gives it a bit more of a comic-y look. And there are like nice shaders you can find online of people doing sort of stuff like that, where they maybe they use the shadows are like just a more blue color, but not that much darker. Maybe you can add some rim lighting and stuff. And that stuff is quite easy to experiment with in the shader, just like play around. So don't worry, like if you don't want to make photorealistic rendering, don't worry about PBR and stuff. I mean, I have the real-time rendering book here. I like that book, the real-time rendering by, I don't know who did it anymore, but I like the basics in there. But then, it goes on about PBR and stuff, and it's quite nice to just be able to skip that. I don't need to know what subsurface scattering is, because I want a clean, simple, like sort of more colorful and playful art style. Yep, the one with the stormtrooper on the cover, that's correct. I have exactly that edition sitting over in the shelf, and it's a great book. But if you don't want the PBR stuff, you can learn the Phong shading stuff just to get a feeling for the direction of lights, making a shadow darker. But then you can play around with recoloring the surface instead, and just see the shader, the fragment shader, as sort of a artist tool instead of scientific lighting stuff. Anyways, that's sort of it. Because then you have instance transforms, and I have my instance UV map. It's probably a better way to do this. But the cool thing here is, we can open RenderDoc. I love opening RenderDoc. This is my favorite activity. I sit alone at home and open RenderDoc. Oh, can I make this bigger? Hello, RenderDoc. Global font scale. Let's just crank it up. So I start my game with RenderDoc, and you see you get a little. Okay, I'm just actually wait. I'm gonna remove the debug drawing in the corner. The nice thing about RenderDoc is that you can inspect. I tried to make. I used instancing, and then I used this atlas, and I tried to make so that everything. I try to experiment. I probably don't need efficient drawing for this, but I just found it interesting to investigate, just to be better at it. So with RenderDoc, you can launch your application like this. And you see you get a little thingy in the upper left corner that says how fast it goes and stuff. And I can press print screen, and that makes RenderDoc grab a frame. So I have in here now a grab frame. I can double click it, and it captures the whole frame. And this is some kind of witchcraft program, right? The font size here is a bit off, but I have a depth only pass here, and then I have a color pass. This is the depth only pass. This is the shadow pass, and we can go to the texture viewer, click the clear color. You see, totally white. draw instance arrays. Here you see it draw the ground. You won't see any difference here because this draws the 2 characters because it's hard to see on this. This one you can ignore. That's my little circle. That's sort of for debug. But this is just what's more interesting is perhaps to look at the color pass. It clears it with black, then it draws the sky dome, then it draws all these things, and here you see it used the shadow map to already here. And this happened at once. This is the instancing, right? Because it drew with one draw call, it drew 36 indices, which is 3 different boxes, because you know the game currently consists of there's one down here, and then there's this one I'm working on, and then there's this one, the tall one here. 3 different boxes. So it drew those 3 at once, including the shadows, and then it draws on the 2 characters. And another cool thing you can do here is you can go to the texture viewer and look at the inputs. So for this one that draws the characters, you see that it has the shadow map as one input, and then it has the texture. And here is the texture, and I can't zoom this really. Maybe I can zoom it here. Yes, I can. And here, this is the texture that has the squirrel and the cat on it. But we can even inspect stuff in here, like we can go to the pipeline state here. And here we can see that the vertex position and the normals. And we can also see the instance UV remap. So if we click this one, this is the one that makes the characters have different UVs. We click the little arrow there. And we can scroll around in here. This is terrible on a small screen. And we can go all the way to the side here, and we can see that, okay, so for this first vertex, these are the remap parameters for the UV that I sent in. And then you can also see here the instance transform matrix. You can inspect the values here. And if something is wrong, sometimes you can spend days debugging it if you don't have a tool like this. Because I had another problem the other day where, because my OpenGL stuff isn't set up very well, so my shadow casting shader had one less, like if you look at the default, no, the shadow, this shader, right? If you compare it to this one has vertex normal here. This one doesn't. So because of this, because of how the GL stuff is set up, and the mesh having sort of this vertex array object, because of that, the vertex normal, when it was drawing the shadowcaster stuff, some of the instance transforms went in and overwrote some stuff in this vertex array object that would later be used for this shader. So this vertex normals will actually overwritten, and they're not written every frame. They're just written once at startup, or once when you load the model. I mean, so I had no idea. I'm like, oh, my normals are broken. I don't know why. But yeah, I used RenderDoc and I looked at it and I saw that I saw in here. I was looking at in this specific view, and I saw that the vertex normal here, the numbers were the same as the first column of the instance transforms, which told me, aha, someone has written this data here. And then I started thinking, wait, maybe something, and I started Googling this, and I wrote some TLDR post in some Discord channel and got confused. And then when I Googled it, I eventually found out, like, oh yeah, this can happen when you have using the same vertex array object with multiple different shaders. You can overwrite some stuff. So my solution right now was to set these locations so that the position, like my instance transform are always at location 6, and this is at location 10, because this one actually takes 4 positions, because it's 4 vectors, essentially, a matrix. But I'm figuring out that without RenderDoc. I don't know how I would have done that. I would just trial and error until something happens. But yeah, this is a great program for just it's so nice also when you try to optimize something and, you know, collapse draw calls into one. Even if you use it for Raylib 2D, you can you can notice that when you, because Raylib 2D has automatic batching, which means that it can combine things with draw calls if they use the same texture essentially, usually. So if you have an atlas you grab rectangles out of instead of drawing with separate texture each time, then in Raylib you can quickly see that when you move from the using separate texture to using atlas, you can see how just lots of draw calls, lots of lines inside the pass here just disappear and become a single one. And it's quite, I don't know, it's somehow quite rewarding to open render doc and see all that collapse down. Anyways, that's that for about that. Davidash asks if I'm using a level editor for this game. Not yet. I'm thinking that maybe I make it a bit, not, maybe I'll whip something together, a little in-game level editor or something, but maybe I'll make it so that it uses sort of a finely meshed grid where I can paint sort of boxes, and then I can say this box should have this sort of material, maybe there's some grass on top then, and then it can draw that with instancing and the atlas, and then just figure out how stretched it is and sort of loop the textures on the sides and stuff. I was thinking something like that. It's not like voxels like in Minecraft, it's more like draw blocks with auto texturing on them somehow. And yeah, but I will get to that soon. This is a lot of this is just me trying to figure out, because, you know, when I did like a 2D game, I think it's fun to, when you make something, to both challenge yourself technically and artistically. So when I made Cat and Onion, the challenging technical things there was that I tried to stay simple, but still sort of try to make the game run somewhat fast. I mean, it can run on my mom's 12-year-old computer at 60 hertz. I was quite happy with that. And I tried to do stuff like just nice animation, and I also tried to experiment with, in that game, with like the player character being able to climb up ledges, so I was doing sort of like technical gameplay programming. And this time I'm trying to more do sort of like, I'm just experimenting now really, but I'm trying to see if I can do like 3D in a fun way. I cannot do a game where I have 3D animated characters, so I have sprite billboard characters that I can animate later and maybe make a couple of directions of, and then I can make some simple, maybe nice pixel chunky textures or something. But yeah, so somehow it excites me. It's a good way for me to get started on a project, to have some technical challenge, and then it also becomes fun to use those things to make a game on top of it somehow. I don't know, something like that. Stefan asks if this is going to be on GitHub like the hot reload. No, I mean, this is a bit too messy to be part of any template. It is currently like I have a separate GitHub account that my patrons have access to, where I put, like, that one contains also the Cat and Onion source code and stuff. Like the patrons who pay the mid-range and upwards get automatic access to that. So it's in there, and it will probably stay there because this might be sort of the game I'm working on. So that's sort of a Patreon tier reward. But yeah, I also have some other small prototypes on that Patreon only GitHub account. But like I said, this is based on the hot reload template. And it's essentially I just mashed together lots of Raylib examples. It's the Raylib instancing example combined with it's the Raylib it's the Raylib lighting example combined with then the shadow casting example and then combined with the instancing. Where in the last step I also added my own instancing, and that's why I have my own draw mesh instanced here. Hello, Gulheim. Okay, but we're done with all that stuff. Let's go into phase 2 of this TED Talk. Let's go into phase 2 of this stream, where I'm just gonna check what the hell did I change in here. Okay, this is fine. Sky dome color. Step 2 was that I was gonna do a cleanup because, like I said, there's lots of commented out code here. I have written some code, I've copied in some code from Raylib examples, I have copied some code from C, translated it to Odin. Everything is just whack in here. So I'm just gonna clean that up, and I think it's kind of easy programming. So we're just gonna start. I'm gonna remove this because this is from my template. So I'm just gonna start and go over stuff like this. All this is fine. I can make a player struct later, but first I wanna fix the obvious stuff. And then I'm gonna obviously move my mic because it's annoying me like that. Okay. So here we have some debug printing that I was doing. We don't need that. This is for rotating the light. We can keep that for now. This is the thing that sets the light position. We can keep that for now. First, I want to just address like very surface level things that are just like obviously like the wrong naming convention or, you know, stuff like that. So this is code I've written. It follows my naming convention. This is probably all fine. Then we get to draw skybox here. Here it uses Raylib. Here is some constant. This is the size. This is all fine. Well, actually, this thing of using indentation to do like, this is copied from somewhere. I'm just gonna collapse that. I don't do like old school GL that much that it matters. I'm just gonna do like this instead. Also, I'm gonna convert all the indentation to tabs because it's inconsistent right now. We can commit that first because I think that will change quite a lot of code. Because I copied in some code, some C code from the Raylib that had the wrong indentation. Here's my draw world. Here I draw the teapot. Yeah, I have a teapot also. I can show you. If you go down here, there is a teapot standing here. But I disabled it because it looks so bad in what's it called? Render doc. When you have, this is like a million vertices. When I try to like, we can delete that one. I don't need it anymore. Here is draw mesh instance. We can remove that. NPC rects. Yeah, we'll figure that out later. We will just do like, it's actually Atlas Rex, which is a bad name from before. Something like this. This is my old code. So here I draw a mesh with a plane. This is my old code that drew the NPCs when I used to use draw mesh. So before I had the instancing of those, I used this. So we can delete that. I disabled backface culling here temporarily because I'm gonna draw this from the shadow, from the light, and sometimes now if I remove this, you see that they only get shadow from the front, but from the back they don't get shadow because they get backface culled because the light source is up here and looking at them from behind. But actually I only need to do that. I mean, I could do like this if but what's it called? Shadow caster. Can do that. Maybe it doesn't matter that much, but oh yeah, I should look into the artifacts like this. Like when you see you get these at some angles, you get this kind of stuff here. I'm not sure if it's the lighting or if it's self-shadowing, but I have to look into that. But that's not that important. So that makes this stuff, and this uses draw mesh instance again. Then we can go into draw. Here we draw into the shadow map and we clear with a white background, and we have the camera here. The camera, yeah, the light stuff I will change later how it works, not important right now. Here we sort of start to see things that use this wrong naming convention. This is coming from the Raylib C example. What you would usually want here is something like this, right? Variables in the Odin standard, like the Odin standard library naming convention, which I follow, uses a snake case here. There is an update coming for, what's it called, OLS, that will introduce so that you can rename, so it will look at symbols. I hope it will work in Sublime as well. We'll see. Is there like a there was a, I can just do this snake gaze, bam. This one maybe I should save somewhere, but yeah, that's not terribly important. So this is the stuff we can just write here. Draw into shadow map. Shadow map done. Draw into draw normally use shadows. Yay. This is some old crap. This is sort of how it looks in the Raylib example code. They do a bit differently. They set up a texture somehow like this. They set the depth like this. I instead set the depth on the material, the depth texture, like you maybe saw. Here I say that this one at slot 10 here is the map number 10 is the depth texture, and the reason it's 10 is because the location I set up here is map albedo plus 10. That this is the thing that sets which texture to use, and this thing here says that the thing at the 10th position is the thing called shadow map, which is the texture sampler inside the shader. Right. And then we can just delete all this. We don't need the begin shader mode anymore. This was my old code for drawing. This was the initial draw billboard. This is the first time I got the sort of squirrel. I had this texture of the squirrel and I drew it as a billboard. You can delete that. This one we can keep for... Let's actually add a fun thing here. Go up to here, and then we say debug draw bool, and then we go to update, and we say if rl.isKeyPressed.f3, and then we say gmem.debug draw is not gmem.debug draw, and then we can use that what's it called? Yeah, here we say if gmem.debug draw. Then we do this, and now I can press F3 to toggle that thing, which is nice. I mean, maybe this thing should also be part of debug draw. There's a little gameplay thing here where I fell down. There's a little, I was toying around with, like, you can press this thing and the character sort of climbs down and then turns around again, and then you're down here. It's just a little sequence I did with a little state machine that sort of transports you into a turnaround state, and it's climbing and then it turns back around again. This is the thing, the crosshair, you see, very simple. There's a crosshair in the middle here, the gray circle. After I'm done with mode 3D, I just say draw circle V at the screen middle, 5 pixels big, crosshair color. And the screen mid is just the screen width and screen height times 0.5. And then the crosshair color is usually gray, but if I walk close to this, then it does a ray cast on it, and it becomes green. And that's just, it just goes over all these points where you can climb currently, and it does this. This is just hacked together gameplay. It's not, it needs a lot more to be generic, because it's currently hard-coded how far down it's gonna climb and stuff. Right. So that's all that. Stefan says, yeah, like Stefan says, the RLGL PR got merged yesterday by Gingerbill. Yeah, so now, like, anyone watching this can just do import RL like this, and then if you want RLGL, you can get it in a separate import like this. And RLGL is, I mean, it's just like a abstraction of OpenGL that sort of looks a bit like immediate mode OpenGL, but you can use it instead of OpenGL if you want to. But it's quite nice because you can start with Raylib, you can load model, draw model with Raylib, and then after a while, maybe you be like me and you go into draw mesh instance. Like, you're looking at this procedure here. This is in the Odin bindings. You see, oh, draw mesh instance, and you try to use it, and then after a while you get fed up with it because it's not doing what you want. So then you look in the C code, and then you see that the C code uses RLGL. Any proc in Raylib starting with RL actually comes from the RL. If you look in rlgl.h here, and like I said, I have the Raylib Odin bindings, and I also have the full Raylib C source code in my project, so I can easily jump around and look at these things, which I think anyone who uses Raylib should have to make their life happier. This is the RLGL source code, and you see every proc in here starts with RL. So what we did was we moved RLGL to a sub-folder, Raylib RLGL, like this. And then I could say link prefix RL, so I could just drop the RL on all the procs, and it ends up under the RLGL import. So in my code, it's an RG, but if you didn't type that, it would be under RLGL, like this. So you can just use all these, and all the constants and stuff have also had the RL underscore dropped, because before there was like this. So you had to type rl.rl underscore. Now you type rl, now you type rlgl.funcadd, for example. But yeah, so it's nice that you can, when you're fed up with something in DrawMesh instance, like if maybe you're fed up with DrawMesh instance, then you can look at it and you see that, oh, this uses a lot of RLGL stuff. Then I copy this to my Odin code. Very easy to translate C code to Odin. I just went over it line by line, just hit compile essentially and fixed things over and over until it compiled. I replaced the obvious things like this stuff here, so it's rg dot instead, and then I started fixing issues as I ran into them by just compiling over and over again. And that way you can I think you can learn GL in a nice way by starting with Raylib 3D and then slowly but surely migrating towards using more and more RLGL. And when you use enough RLGL, you're essentially using OpenGL. It's just slightly simplified in some ways. So then you can, and you know, I do kind of all the time. I do stuff like draw machines, blah blah blah, and I'm maybe I'm down here and I'm like, okay, what does actually rg.load vertex buffer do? Well, then I go to symbol and I type rl load vertex buffer. What's this one? And then I go to the definition of this procedure, and this is the code in RLGL for this one, and then I see, okay, it does, I see the raw OpenGL things it does. Okay, it generates a buffer, binds it, and then uploads some data to it. So then I know after this thing is run, it will also be bound. So I don't need to bind it. This is just a way to generate, bind, and upload data and not unbind it afterwards. So I can do more things to that buffer, which is what I do down here. But yeah. So we fixed all that. Okay, let's leave update and go to, well, let's leave that update proc, go to this one. This thing, this one I delete. The window is currently called Teapot Tycoon because the first thing that I drew was the teapot. It's probably not gonna be a game about selling tea. It would be cool to have Transport Tycoon, but instead of trains, there's tea. But yeah, not sure about that. This is the camera. This one is fine. Check collision boxes. This thing checks if to. This is should be like that. So here's the thing: when you port things from C, in C you need a parenthesis around everything. You don't need that in Odin. Well, not if statement, I mean. So this is more correct. This thing returns how much two bounding boxes, 3D bounding boxes overlap. So it gives you sort of the intersection of them. So if you have two boxes that sort of point into each other a bit, this thing gives the intersection and also says if they collided. And I use this for my very, very crappy collision detection currently that I need to replace at some point. But I might replace it with a walk mesh. I don't want to spend a lot of time on putting in like either integrating a physics engine or writing some custom physics, when I think maybe I'll just generate sort of a nav mesh thing so I can just walk on the surface and then maybe walk up to something like this. It climbs down and then I'm standing on another walkable surface. Don't need to go crazy with tech things before you know you need them. Here is my shader location UVs, and now we get to the thing that has lots of things that needs to be fixed. Let's just save that. This all works fine still, yeah. So we have some cleanup there. So this comment I don't need anymore. Don't need a comment. It binds the shader. Well, the line says it does that. So this one I have, like I said, I copied this from rmodels.c. I took this code in C and pasted it here, and then I started translating it. So let's clean this up. Color diffuse. I could delete this stuff. I can leave stuff like this for now. It doesn't hurt, but maybe as I decide more on what shader parameters I need, I can remove, because I don't have a specular color right now because I turned off specular highlights completely. What does this comment? This is, like I said, this is from Raylib. This I haven't written this comment. Get a copy of the current matrices to work with. Oh yeah, this is all a bit strange here. This one is for some reason defined up here, but it could just as well be defined down here like that, just colon equals blah blah blah. Matte view is used immediately. Matte projection used immediately. Okay, that's good. So it fetches the matrix model. Get matrix model view, matte view. These names kind of matrix model view, matte view. Okay, but was it the matrix? Like, I might be wrong, but model view is to me the world, local to world transform combined with the matrix, the view matrix, which is the inverse transform of the camera. But in this case, it's just the view. So, yeah, but I might change these things up a bit, but currently we're just cleaning up. This parentheses come from the C code, don't need that. This is just me, because these must be the same length, otherwise something has gone terribly wrong. I don't usually put this much comments, just they're already there because of... They're just already there, so I tend to edit a few of them. All right, yeah, I'm forgetting what we're gonna do. We were supposed to make this the snake case. So, you know, the Raylib procedures are upper camel case like this, and that's fine. I mean, that's... We couldn't make new bindings for Raylib that follows the Odin, like the Odin standard library, but it's just easier. Like, if it says like this, then it's very easy for me to go and find it in the source of RLGL. I don't need to, like, especially for the Raylib stuff, like I can rl.init window, I can press F12 and either go to the binding or go down to the C file and see what it actually does, since it has the same name. For RLGL it's almost true, but since we dropped the RL in front, you have to normally manually. You see, this is the binding and this is the one in the C code, so you can go here and look what it does. Yeah, I think it's better to, like you say, Stefan, I think it's better in bindings to keep the original name. The only thing I would say, if you have a C style, prefix where the prefix is in the name to make sure there's no global namespace collisions, then I would say just like this, put the link prefix on your bindings and drop them. Because otherwise, I mean, in Odin you're forced to have a package prefix of the imported thing anyways. So that's sort of one of the reasons I pushed for this to being put in here. Also because RLGL is supposed to be independent, and it was before that inside the Raylib package, and it felt like a bit mushed together. So I thought that would be good. Okay. Matte projection, matte view. We have some compilation errors because we, like I said, we might get We might get a rename support in OLS soon. That would be cool. That all looks good. Let's continue. Instance transforms. Okay. Snake case. Instance UV remaps. Oops. And this is not really UV rects. This is incorrectly named. This is Atlas rects. This is the rectangles in the atlas where we want to pick the texture that we use for these two, so it knows. Right. Here it enables the vertex array object, and this is the thing that gave me trouble. There is a one vertex array object per mesh, and it has preset up so that the positions and the normals and the text codes are all at nice positions, but then this thing also writes in the, this thing writes in the transforms and the UV remaps. They're sort of, this is like a dictionary, like where, like it's sort of like a mapping. Where are the things that the shader needs? Where do I find them? So this thing writes into the vertex array object, and depending on which shader you have bound, what material.shader.locks maps to will actually vary. So in my case, when I was doing this, I had a problem where my vertex normals got overwritten when I used this with a shader, with one shader, and then tried to use it with a shader that had more attributes. So that's why we have this situation here. This one, here I say that the location is 0, 1, 2, 6, and 10, and then shadow caster instance here it's 0, 1, 6, and 10. So I force this one to be at location 6, because before this one was like, okay, I'm gonna be at location 2. At location 2 you had the vertex normals, so they got overwritten. Well, not really overwritten, but they're sort of their lookup in the vertex array object got overwritten. Vertex array object seems to be a messy thing that I still haven't really wrapped my head around how to properly handle. Some people say that you can use one global, and if I had a later version of GL than Raylib uses, maybe I could do something more fancy. I mean, I programmed a bit of Vulkan at some point, and when you use that, then you also have, descriptor sets and stuff, which I think sort of does similar stuff, like where does the thing drawing with the shader find stuff and things, but yeah. Anyways, blah blah blah. So we enable the vertex array here. This is because we need to use it here to write stuff. And then we load the whole instance transforms. I know this thing currently loads the whole thing and then throws it away at the end. I can maybe look into how to do this better. Maybe I can have one buffer that's like the static things and one thing for things that are moving, updating every frame. Because if things are moving, you need to update the instances. But yeah, I don't know. This is just a comment that's explaining what's a good idea and not, whatever. This one we can uncomment, I think. It doesn't hurt. Oh, Atlas rects. This should say. This all still works fine. Okay. The instance VBO ID. Snake case. Oh no, I did the code folding. How do I? Oh, there we go. Sometimes I do that, and I do not know how to get out of it. And why is this? This is instances. Yeah, it's the transforms VBO ID. Right. And all this, because GL keeps a lot of state around, you know, this is quite weird because you create a thing here, and then these things that are supposed to sort of say where things are in this buffer, this sort of says how, this thing sort of says how, where is each, for each instance you're trying to draw, where are the different parts of the matrix located and stuff. But it doesn't like mention this thing here, because GL keeps state around, you know, load vertex buffer, RL load vertex buffer. It binds the buffer, so it knows which buffer is bound and stuff. It's quite funny that set vertex attribute takes a pointer as last thing, but that pointer is supposed to start 0. It means the start of the like it's just an offset. So I don't know why they use a pointer there, because it feels more like a byte offset, because this one will be like 0. Yeah, it will just count up here, like size of a vector 4 times I, and it's because there's 4 of them, because blah blah blah. Anyways, it's all a bit funny. Here I'm thinking what I should do. Hello Sublime CS. The reason I take out this thing here, if I do like this, does it use I over here? Okay, let's just do like this. U32 I. Yeah, that's fine. Then we go down here, UV remaps VBOID. Let's snake case that one. This is all fine. Okay, this one maybe could have some love. It just looks like a pile of something. This is like the offset of each of the parts of the matrix. How do I... This transmutes into a raw pointer. This thing here, size of... Let's go here. Oh, I have VEC4. Okay, well that's better already. And then, yeah. Actually, I don't mind. Since it says 16 F32 here, I can just as well say 4 F32 here. I don't care if I use the word vector or not. Okay, so here this is for creating the instance UV remaps that I need to look into the atlas. This all looks fine. You need to compile every now and then we do stuff like this. Check that nothing broke, because otherwise you might do 10 things and then you notice that everything is broken. And this stuff here, there's actually a bug in Raylib that I should report or pull request in that I fixed. Here it sets the matrix normal, but it sets it, the thing it sets it to in the original code is, it probably won't do any harm, but it's just not correct. Because if you look here, this is the C code. This one is like a matrix normal, and then it's like the matrix transpose of the inverse of the model matrix. maybe it's not wrong, but I was thinking that it should use the current matrix transform if you have pushed on any matrices. Whatever. Maybe it's correct. Anyways. So, where are we? Matrix model view. Where is this used? Okay, it's used down there. Why? Okay. This is kind of things that make me confused. Why is it even created here if it's not even used here? Let's go down to where it is used. So you take, because there is no model view, this is just the view matrix times the, you might have pushed on a matrix on top of it. This we can remove. Also, there's currently sort of a problem. Matrix multiply in the array math says this is left and this is right hand. I have to reverse them, and I think this is due to how Raylib sort of stores things row major but pretends they're column major, which is, you can have opinions about. And I think, I'm not exactly sure why it happens, but going row to column major is essentially a transpose of a matrix. And if you multiply two transposed matrices, then you flip the order, then the transpose sort of moves. But yeah, anyways, I have to do this to make it correct. And here you see again, math model views here. Here it was on the right side, here. And this one just multiplies left and right. But anyways. So this is just, can't we just do this? So this is not model view projection. This is just view projection because there is no model matrix really. At least that's how I see it. When you use instancing, you don't really have a model matrix because that one's fed on a per instance, right? But we still feed it to MVP there. I can fix that later if I make everything more custom. Let's see if that compiles nicely. Runs, yes. Okay, let's go back because I moved some code down. We need to go over this in sequence. So we've done this stuff, and then we're in here. Here we upload the model normal matrix, which is the stuff I just looked at and talked about. These parentheses are not necessary. This whole matrix upload is not really necessary unless you happen to have something pushed onto the matrix stack. Otherwise, this will probably be identity matrix. Doesn't do anything. We can actually go to here. I don't even think I don't want to. Somehow this should probably be multiplied in here so you can use that pushed matrix. But since I don't use that, I mean, I don't need to solve all the problems in the world here. Here it binds the texture maps. This is sort of material management stuff. In the original raw mesh instance, in the original one, it uses max material maps here. This is defined in config.h in Raylib. Not even available in the Odin binding, so I just hard-coded it here since I know what it is for the version of Raylib that I've compiled with, but yeah. So I loop over all the material maps, and here is a thing there was a compiler bug here that should be fixed now, where it crashed if I used... I don't think this should be possible, right? Yeah, cannot take address point, cannot take pointer of this thing, because this thing is a loop variable and that's not allowed. So therefore I took out a local... I said II, and then I took out a local version of it here. And I also cast it to I32 so I can use it with all these procedures without having to cast it. Let me just blah 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 a bit here. This is okay. I don't love this, but I don't know what to... It's just, you know, interacting with for a, like a C API. So this parenthesis I can drop. Oh yeah, now comes the fun stuff here. So you see here I say enable vertex array blah blah blah, and originally there is an if statement here that if it can't do this, then it does all this stuff like blah. I haven't even properly migrated this from C to Odin, because if you look at, for example, load model, so this is another good reason to have source code. You can just figure things out and like make sure how things are working. You know, here we have load model. It runs upload mesh. You're looking upload mesh. Okay. Oh wait, upload mesh. What does upload mesh do? It's like, okay, it sets these VBOs IDs, which is what this thing uses as a fallback if it can't use the vertex array object, right? And it sets the vertex array object to 0 here. But if we have OpenGL 3.3 or higher, which I know I do because that's what this version of Raylib is compiled with, then it just sets the vertex array ID, vertex array object ID here, and sets everything up. So I can be sure that this thing will be set. So I can be sure that this whole block is not necessary. So therefore I can remove all this. And now we got back to here where I moved some code. Don't need that comment. And this, so this calculates the view matrix. I'm just going to check that this still works advertised. Since I moved some matrix multiplications around, this looks good. Shadows are still okay. I don't even need this block anymore here. I don't know what a block was there. I think it was because there was another thing, you know, there was something here for in draw mesh instance in C code. They had is stereo render enabled. This is for VR headsets, so you have eyes and kind of eye count. I'm not even gonna bother with that right now, but I could just port this back. But I just pretend that eye count was 1, and then I looked at this code and I started removing things. And then, you know, I was left with this. No, I was left with this plus this stuff, which is this stuff here. So here it draws the mesh, and it will this is if we don't have indices, it does this, and if it has indices, it does that. That's all fine. And then it unbinds all bound texture maps, blah blah blah. Here we can remove. This is all wrong coding standard. Haven't been here yet. Can actually remove all these parentheses. Not needed. Right. It's just a cast to this enum type, so I can compare against it. I can do the same here, move it in here. Good, good. Disable texture, disable program, unload. There you go. It all still works nicely. Woo! So that's sort of my own draw mesh instance that both has transforms and some weird rectangles that I can send in, and it all gets fed to it. And I can probably remove even more stuff later. Maybe I can remove this color specular, and maybe I can remove, and maybe I can rename so it doesn't use the matrix model shader location index, because I have all that control now, so I can play around with that. Good, good. And since everything works correctly, we will go and here we will type git status. Just check a bit here. And cleanup of draw mesh instanced. Mostly deletions because I removed so much code. Right. Okay, so we get game init then. I'm just gonna first look in the game memory here, see if to remove the teapot. This is not used. Climb points, we use Atlas plane mesh plane. Yeah. Plane we don't use. The shadow map we use. The cube we don't really use. Fix those compile errors. Okay, bye-bye. Bye-bye. It compiles again. Play, it's fine. Okay. So game init. This is probably mostly fine. It sets up the game memory. Then it sets up my different things here. One thing that I was curious about that was broken when we were trying things, that I can fix default lighting with fragment shaders. This darkening thing, I had some kind of distance darkening. I was thinking that maybe further away things are a bit darker. It seemed to not work because it's supposed to be relative to the view position. But you see, I'm standing over here. It's supposed to be this slightly darker area is supposed to follow me. So let's check why. View pos. Frag position must be correct, otherwise nothing would work. So view position must be wrong. View position is coming in here. It's a uniform vector 3. I think I know what's wrong. Because we set view pos on the default shader and the default shader instanced, but vector view, if we go down here, yep, this is it. I have to figure out a better system for this, but we have default shader instance. You need to set this one on both shaders. Like this. Now, you see this is how it's supposed to be. You see it's like some kind of, I don't know. It's some kind of something. I was just experimenting with rendering things, and it's supposed to be a bit less strong. It's supposed to, I was thinking that it's just it's barely noticeable. Yeah, now it's a bit darker there and I come close. I don't know. It's just me playing around. What was I doing? Game init. Roger says, seeing your cat in 3D feels so wrong. Yeah, it's very strange. It's like, I kind of think it's very funny. I liked, I increased the FOV to like 160. So it was like this, and then I go up to it and I'm like, oh, what's going on? Hi, squirrel. It's just a, hi guys, how you doing? Yeah, it's more or less a test thing. But I kind of interested in trying to do... I'm kind of trying to do sort of a thing where maybe I draw... I draw new characters, but I draw them from 4 directions. So one front that's looking forward, and one from... Like, maybe I draw them from 3 directions. I draw front, side, and back. And then I can just, if I walk, like if the character is looking this direction, then it's now looking towards me, and if I stand here, I see the side, and then I see the back. It sort of snaps at 90-degree rotations, and then maybe the shadow also snaps. I don't know, it might look interesting or totally horrible, but that way I can, because I can't make 3D models, because then I might have to animate them, and that's not gonna work. That's not gonna never have, I mean, that's sort of the difference between making a 3D game yourself. Like, I think the thing that eats millions and millions and millions when you're making AAA games is nice animations, especially if those animations are supposed to sort of maybe, like, you know, one character is supposed to smoothly give another character an item, like someone said that one of the hardest animations in one of the Horizon games or whatever they call this, when 2 characters hug, because they're supposed to dynamically do it. You know, it's like 2 animations that 2 separate characters are supposed to kind of do like something that's has all the offsets correct and everything, combined with also making those animations and making them not uncanny and horrible. Yeah, I think that's the having good 3D animations is then good 3D animations with lots of interaction between different animating characters. It's one of the reasons why AAA games cost millions, but just one of them. Hello, Rip Van Winkle. Rip says that I had wishlisted your games on Steam a month ago. Thank you. And you're going to start learning Odin in a few days. That's nice. Then you can, I hope, maybe some people watched so I haven't been streaming much the last month. I was doing this the snake Odin tutorial, 1.5 hour long tutorial. Actually, the recorded material for that one is 3.5 hours of retakes and me just thinking and staring at the camera and whatever. And it took me 6 hours to edit after that. And it took me like a day before that to write the code, because you first need to write the code for a snake game, and then you need to split it up into, you know, steps that I could do that made sense one after another, and all that. So that took a lot of time, so I haven't been able to stream that much because and then also I've been just experimenting so much that I didn't really have, like, it was just me, lots of these things were just me staring at the computer and swearing because my light map wasn't working correctly and stuff, which some people enjoy watching, but yeah, I was, yeah, it's what it is. Yeah, the Odin cult keeps growing. Okay, so game init. This is fine. Matte view post shadow map. I think all these are needed. Some of the matrices in some cases are not set up correctly. Unknown asks, I notice you use bounding box. Is it aligned or oriented? So bounding box in Raylib is just, this is an axis oriented bounding box. I don't currently have anything non-axis aligned here. And because also the physics I've coded is just a hack currently. Bye-bye, RIP. The physics I have is currently just hacked together. I would say like, yeah, you can make your own physics if you put in aligned stuff. I mean, an aligned box is just, there's many ways to do that. You could just have position a size and a rotation or something. I don't know. There's also, if you use Odin, there is someone made like the physics engine Jolt. Someone made bindings for that. If you want to cheat a bit and have a physics engine. But yeah. So let's finish cleaning up this init proc. The default mat we need, the default mat instance we need, shadow casting material, shadow casting mat instance. Odin doesn't have Jolt built in like Raylib, but there are bindings that work fine. I will send you a link in the chat. First, I was just gonna send this link. This is a list of great Odin libraries and stuff. And if you search for Jolt in there, then you will get to this GitLab page. These haven't been updated for 4 months, I realize, but they might still be fine. There was a person in the Odin Discord developing this, and it seemed to work okay. You can try it, but that's the only big physics engine I think that has bindings. Only 3D physics engine that has bindings currently is Jolt. I don't know how it. I hope there is some good documentation in there how to use it. I haven't looked at it, so yeah. But yeah, you're welcome. Is it for Windows only? Is it? Yeah, it's for. Well, it is currently for Windows only, but the only thing you need to do to get it on Linux is to build Jolt binaries and set. Well, there is some Linux stuff here. I think maybe the comment is old. Because there is a jolt binding.sh, and let's have a look at, I think, does this, yeah, you see Windows, Linux, and Darwin, which means OS X. It's all in there. So you can try downloading that and see if you can get it running on your Linux or Mac OS or whatever you use. And there is a test. There's a file here that tests does some stuff. But yeah, I haven't tried this. That's the only 3D physics engine I know of that has bindings. This ambient color, do I use that? I don't really use that. Well, I can keep it. It doesn't matter. And maybe I will add in ambient light. Here is the material. Okay, this stuff I don't use. This is because game memory box is a model. I don't use the material on it. This is sort of a thing that I don't like that much, that maybe I should just do this box mesh rl.mesh. Let's try this. I mean, I had this before and I removed it, but I realized gen mesh. Why is my my OLS seems to have gone to lunch. I don't know. Let's go look at manually. Width, height, length. Oh, okay, 111. So we make a box mesh instead. Then we go down here and we delete this. We go up here and this is the load model here. I removed that. And then we go up here and we remove box RL model. Then we do like this, NPCs, go here, this is the box, and here we say just box. No, cube maybe it's called now. Cube. What the hell? Oh yeah, called box mesh. This should still work. Yeah. So RL load model is great for when you just load a model and draw it, but it sort of creates like lists of, it figures out sort of like, oh, what's all the materials, sort of loading material files, and then something more minimalistic like this. I'm just interested in putting out boxes and planes, and then I know what material or even shader plus settings to use. I don't care about what's in the model, so that's why I deleted that. Non-unknown asks, in your 2D game you made, how did you deal with entities? Because suppose a player has some attributes that other entities doesn't have, so you can't use composition. Yeah, there's a couple of different ways you can do it. You can use... There's an example in demo.odin. There is like, for example, you can do stuff like you can say that an entity has a union on it with like variants. This is called derived, but I would say that it's kind of variant. So you can have player here, and then you can fetch the variant on the entity if it's the player, and then do something to it. Then of course the entity will be as big as like it will grow. The union will always be as big as the biggest thing, but in a small game that doesn't matter. What you can also do is do the sort of big entity struct, which is the most sort of simple-minded thing that might work, because you just put all these, whatever, put them all, just delete this, there you go. And then the player will only use some of these. It might sound messy, but some games do that. I think, what's it called, like Spelunky or something, I think does something like this. You just have a giant entity where things can poke on things. You can get like emergent behaviors. When you have stuff like this, you have to kind of always get the thing on the player, or the frog in this case, and do something. It can get a bit like, because you need to check, oh, is the entity a player? If it is a player, then do this. In my game, I also have I'm gonna link you a video about that, because I made a video exactly about this that you can watch. Yeah, Stefano asked, what's up with the new entity method in the demo? Yeah, I wouldn't do this. I mean, I would store all entities on a list. I wouldn't allocate them separately, if that's what you're getting at. I would, like, the nice thing about having it like this is that you can have a list of entities that's not separately allocated. And if you do like that, then you can't really have this, well, but so the one problem here is that maybe you can't have it like this, because if you don't allocate them separately, you can't have this pointer here. So I have a separate video on that. I don't know, maybe you've watched that already. It sounds like it, but where I put it. Entity, this one, I think. The timestamp from it. That one. What I essentially, I in my game, I can just bring up the source code for the other game. In my 2D game, I have this thing called entity instance, which is a generic thing that says it's using this entity pointer and then the variant. So I can sort of get entity, and I say, okay, here's a handle, and these are sort of like numbers, like indices into an array. It says get entity at this one of this type, and then it checks the variant of it and then constructs an entity instance like this. This means that I can access anything in the entity and anything in the variant on the entity instance with the dot, sort of. But yeah, I ended up moving a lot of things to entity and didn't actually use this that much because I realized I didn't need it. But if you want to, you can do something like that maybe. I see what Stefan is asking about. So you're asking, is this procedure making an entity struct then a derived? So this is the demo file that comes with the Odin compiler. You're asking, is it making an entity struct then a derived data with a backwards pointer to the entity struct part? Yeah, it's just so you get a type here. So you say new entity monster. So it's this struct here. And then it knows, okay, then it makes a new entity. And since the union here can hold whichever type you want, so then you say, okay, the union needs to have the type monster. It should have a value of the type monster, which is the type we sent in here. And then it sets on that one the pointer back to this entity, so that when you just have a monster object, sort of say that you just handle a monster, you can still fetch the position because it's using the entity. This means that all of to the programmer, it looks like all of these are just there, but they're not. They're actually going via pointer to this one. But yeah, this is all interesting, but if you ask me, I wouldn't do this part because it's a nice thing about having just structs like this is that you can store them on a list without having each separately allocated. But if you don't have them separately allocated, then that list can grow, and then maybe you can't do this. But one thing, if you use a static list, so you use a list that can't grow, say maybe you say that entities is 4096 of entity, and then you just somehow, you just fetch one thing in here, and you can maximum have this many entities. In that case, you can store a pointer. Like then you can actually do this without the separate allocation, because you can just fetch an unused slot in this thing. You can somehow keep track of which are unused, fetch an unused one, use that one, and then set the entity pointer to that one, because it won't move. So you're not gonna get a dangling pointer to this one, because so the only thing I think to do this is either to separately allocate them or use a fixed array, or maybe some virtual memory tricks. But yeah. Oh, I mean cat and onion. Close that. Wrong game. This sets a light. We can remove that. This is just one extra box. Where is this box? I just want to see. Where are you? Ugh. Oh, it's a roof. Oh, look at the shadow. So interesting. Like how the shadow, I think it works quite nicely with this billboard. You see the shadow actually clips the arrow here on the top. Can move it, make it 1 meter Wait, which one was it? One can make it 1 meter wider. You see how it sort of covers half that one. It looks okay actually. Just that's some angles it can get a bit distorted like this, but that's just because I am not rendering programmer and I'm just figuring these things out as I go. I can leave that one there for now. Right. Yeah, game done, ship it. I can climb down. I can go to the red ball, press E. Bye guys. Climb down. There used to be a teapot down here, but I removed it. So you came down here and then it was the magical teapot. But, and then you can't get up, so you have to jump and fall forever. Bye bye. I think it will clip through the sky dome eventually. Or the far plane, whichever comes first. Oh, you can start seeing the seams of the skybox because my rendering programming is interesting. Oh well. Right, here is the Create Shadow Map RT. This is also copied from the Raylib examples. So we will have 2. What's the difference between load frame buffer and just create render target? I mean load render texture. What does load render texture do? Okay. Oh, okay, I see. Load render texture in Raylib runs load frame buffer and sets up both a depth and a color. Right. However, in this procedure create shadow map RT, which comes from the example in the shadow mapping example that I will link in the description of this video, and I linked in the chat earlier. That procedure essentially takes the load render texture. They have essentially taken this one, just like I took the draw mesh instance. I've taken this one and simplified it. So they removed the texture. It's just the depth left. You see. So it loads an empty frame buffer and then it sets up the depth texture because that's all it needs to draw the shadow map. So let's do some stuff here. So we're gonna start by doing that. Just cleaning up. Enable frame buffer target. We don't need a color texture for the shadow map. That's correct. This is a very confusing comment. I tried to figure out what pixel format 19 is, because you have pixel format here. It goes to 25, 19 is like here, or maybe this one. That's a compressed format, but it's actually supposed... Oh, right, because it's not a pixel format, it's a depth texture format. So I don't think those use the same, maybe. So which... I think this is just a bit of a Raylib funny thing. I don't think this is supposed to have... Maybe the format here shouldn't even be this enum. Maybe it should just be an int32 or something. I don't know. Other than that, this looks fine. Right. Here is set light. This is from the light example for Raylib. I've just currently go straight into the shader and set the, like if you look in default lighting.fs, there is a light that's up to 4 long that has these different things. And you set things. I currently don't even set the target because for directional light I currently point them at origin because I'm just doing some testing code. So, but maybe I should have some light struct and sort of mirror that instead from this, but I can keep this for now. I just change that when I need it. And that's that. We have cleaned this stuff up a bit. Good. Let's maybe go back here, and there are some things I want to collapse here. I want to take player is a struct that has these things in it. The position, the velocity, and the state. And then it has the yaw and the pitch. This is for the camera. Mouse cache, climb points, blah, 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 blah. This is also... This is the time when the... This is the time when the state started. So then we say here, player is a player, and then we get 1,000 compile errors. Then we just fix those. We can just do this also. P equals pointer to gmem.player. So we say like that. Then we can down here just say p.yaw and p.pitch, p.yaw and p.vel. This is more like the camera yaw and camera pitch, but I can rename that later. State start. Oh yeah, another thing. Let's do that first. I'm gonna fix it so that the state start is when it went into a state. So it's in the default state, and then it's the climb start state, then it's the climb down and climb end. Why don't I use more? No, we do. Yeah, p. So here we will do p.state, and this is p.pos. And here we say start. Yaw, start, yaw, state, velocity position. Okay, where is the last vel? It's down there. Let's just p.vel. p.pos. Okay, good. Player.pos. You might wonder, why am I offsetting this is the position the camera is looking at the player from, and the position of it is the light pos, and then the target is the player pos. Actually, what my camera does is that it sits at the position of the light pos and then looks at the origin, right? But since it's an orthographic projection, and since you have a limited resolution on the shadow map, I sort of move the camera, I offset it with where the player is, so it still gets the same angle of the light. It's just looking at different spots, so it captures the area around the player more and not just staring at the origin. But it gives the correct angle and data in the texture. La 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 la. La 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 la. Okay, here's some state stuff. This code is not even supposed to... This is in draw. This code needs to be moved. I think I just have it in here because I want to change the crosshair color. But I can fix that later. After I've done this. I'm going to try to move it. See, everything still works fine. It feels a bit weird to look at because in my other game you play as this one. So now I'm just... This feels like, you know, you met these two in a dark alley. Last thing you see. Right. That added a player struct. I moved that out a bit. Git that diff. Git diff. Exactly. Blah, 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 blah. Right, so we have that. And then there was something more I was talked about to do. Player, how was it? Oh yeah, there were several different things. Do a player set state. So procedure takes a state that is a player state. What's it called? Player state. Isn't that a thing? Yeah, it's a union. So then we say gmem.player.statetime equals gmem.time, and then we say also. This is just so I have a procedure to do this. State start. Because I will always want to set this variable, right? So then I can go around and look for these. And I can say like this instead. Set player state. And then I just feed it this thing and remove that. Because I was hacking in that stuff before. Right, set player. Oh, this is the other thing I want to fix. I want to move this thing out of the draw. Right, this should still work fine. Still go over here and climb down. And it's quite fun. Now, once I get more of the rendering stuff done, I think it'll be fun to do some more gameplay. Maybe I'll need to do that. I talked about doing also this sort of maybe I want a walk mesh so you can't just walk anywhere, because if you want to make some kind of exploratory gameplay where maybe you find items like a rope, then if you can just jump down, then you know, well, you don't need a rope. But if it's like, okay, you could add fall damage, so if you jump down without a rope, you're squashed. Or you can make so that the whole, you put like a nav mesh or walk surface everywhere, and then the player can actually only walk on a walk surface. You just clamp it to the nearest point. And then this thing just transports you between two sort of nav meshes. I don't know. Rogers asks, how are you doing collision right now? Just iterating the boxes. Yep. I just put in something to, because I didn't want to spend time on advanced physics things right now. I would rather, if I want like something, you know, that supports arbitrary rotated boxes and lots of them, maybe I would try to put in Jolt instead or something. But right now, it's this horrendous thing here that it first applies the position in the Y direction, then checks all the boxes, but only corrects in the Y direction, and then it goes over X direction, it goes over all boxes, but only corrects in the X direction, and then the Z direction. This method actually works quite fine. I use this method in Cat and Onion in only 2 dimensions, and it's perfectly fast iterating over the collision boxes. It works perfectly fine. In 3D, however, having 1 more dimension and stuff, I wouldn't do this. Maybe if you had some acceleration structure where you can only know which boxes are close and around you, you could probably take all the boxes, walkable boxes in the world, and sort of grid up the whole world and just fetch the ones that are in the one that you're currently in or nearby, and then do this, and it might work, because what you see is this method actually gets almost perfect collisions. Like I can't jump on walls. I slide on surfaces like you expect, and it doesn't do no separating axis test. It doesn't do any GJK stuff. It's literally taking the player position. Like if you have a world where you have lots of physics objects that can fall over and interact with each other, then you need something, right, that does something fancy. But if the only thing that's going to have some kind of physics is the player, so just one object needs to check against other objects just to make sure you can traverse the space correctly, then you could just loop over the boxes. And like I said, this currently loops over all boxes in the world, but you could make an acceleration structure to fetch nearby boxes and just do this. If you're only going to have physics on the player, I think that will work perfectly fine. And it's much more stable. Like I haven't found any issues with this at all yet. But it only supports axis-aligned bounding boxes and stuff. Yeah, it only supports axis-aligned bounding boxes. But it's a good start because it's so easy, right? So I could forget about physics for a while and focus on my rendering without having buggy physics by just doing this thing here. And what this thing does is, I can just show quickly. This takes the velocity in the Y direction and adds it to the position. Then it loops over all the boxes and fetches the bounding box for each box. And then it calculates how much the player bounding box overlaps with this one. And then if they do overlap, which is what col bool says here, then it checks the sign, which is if you're above or below it. And then it calculates how big the overlap is by taking the max minus the min of the overlap bounding box times the sign. And that's how much it moves you by to get you back out of collision. And then it zeroes your velocity in Y, and then it says you're grounded. Grounded is just a local variable that's checked at the bottom to see if you're allowed to jump. You're not allowed to jump if you didn't fall, like if gravity didn't accelerate you this frame slightly into a bounding box below you. And then in X direction it moves you like this, and then it does the same thing except that there's no grounded thing here. I realized maybe there's one way to jump in the air here. No? Why can't I? Shouldn't I be able to just run into this thing? And I don't know why I thought I could be able to glitch it this way. But yeah, very quick and dirty collision detection and handling. One thing you need to do, this should be DT. One thing you need to do here also is, DT is the same, but it's capped at a value. You probably need to put in a fixed step physics here, so you have an accumulator and check how many physics steps you should have, and then you maybe try to blend between them, and then you can get really perfect sort of, even though you get a big delta time or whatever, or different frame rates, it will always behave correctly. You can't fall through ground by having a big delta time. Currently my delta time is just locked at max 30 ms or something. But in Cat and Onion I did this, but only in 2 dimensions. And I also iterate, I make a loop. I have a physics time step and I loop as many times as it needs for the accumulated time that frame. And then it also does an interpolation for the last bit of time so that it nicely. But there's a article about that called Fix Your Time Step. I will link that one. This one, I've shown this in videos before. This one, that one is quite good. I know, I just went on a tangent here, started talking about everything. So we fixed the player set state. So is state start only set there now? Yes. Right, and then there was one more thing. There was I think this might be the last thing for today here. Maybe. This thing. Looping over all the climb points. Yeah, this is the kind of code that I don't love this when I must do this. I can either cache some state that I could have some frames. Maybe I haven't tried doing that. Maybe that would be interesting. Maybe update can return frame state. I'm just playing around with some idea here. Frame state is a struct that's crosshair color is a RL color, and then I say that this is a frame state, and I say the crosshair color is dot gray, rl.gray is not that enum, and then I go back to draw, and I take sort of this code, go down to the bottom here maybe. Do I have the camera in here is the question. Oh, okay. Well, I can get it. Cam equals game camera. So then I loop over all the climb points. And then, oh, this shouldn't be here. Oh, good. Okay. Delete this. I copied too much code. I think. Yeah. Climb point. See in get blah blah. Draw sphere. Okay, this thing. This is a debug thing. Should not be here. This get ray collision sphere R with mouse ray. I can call this. This does a ray cast. What? Ah, it's like that. Right. And then it sets the state here. And then there's a yeah, and then I need to return fs here, which is my new frame state, right? I was just thinking if I can make like a nice game update, and then I say frame state like that, and then I send that into draw, so I don't have to redo as much stuff. I was thinking that's my intention anyways. So then I can just say frame state dot crosshair color like that, And then here, I don't need to do any of this. The only thing I need to do here is if, yeah, we can do like this. We can take this thing here, go down here, put that there. So if you're debug drawing, yeah, then it draws all the climb points, which is the red sphere. Well, okay, right now I'm just gonna, this wouldn't work anyway since it's outside the mode 3D, I realize. But also, I don't have any other graphical representation for them right now, so that needs to stay. But I don't need a raycast. I need the screen middle. But you have the crosshair color there. Let me just check something. Do I need the screen middle cam? Okay, yeah, good. And now, hopefully, I can do this, and this turns green. That's quite neat, just because it's often a thing where you have some stuff that's, you need to store some state between update and draw, but it is, that state is only valid for this frame. So it's kind of unnecessary to put it on a global state blob, you know, like put it in the persistent memory. Instead, I can just return a little struct from update with some frame parameters like that. So crosshair color. Right. Good, good, good. Now this one doesn't do anything crazy anymore. Like draw is mostly drawing. Move this one down here. Right. Cool. I think that's that for today. If you like my stuff and want to support me, then you can become a Patreon. Patreons get access both to my previous game Cat and Onion, which, to be fair, you can buy it on itch also to get the source for, but also Patreons get all my current prototypes and bigger projects. So like some things I put out for free, like the hot reload template and stuff. But for example, this little 3D game prototype, that prototype is on my GitHub subscribers organization, which Patreons who pay the medium tier can get access to. But also, if you want to support me in any way, maybe if you like my videos or something, then I'm very thankful for any support. Anyways, if you want to chat more about game dev, then I have a nice Discord server that you are very welcome to join. I can drop the link in the... It's a friendly place to talk about game dev, really. I try to keep it very nice and friendly. And there's lots of Odin game dev discussion and stuff. The link to join is in the chat, and I will put it also in the description of this video. Thank you all for watching my little stream. Have a super nice day and happy programming. Bye bye.